Good morning, Year 10. Today we're going to be solving quadratic equations using a new method, which is the quadratic formula. But I'm going to derive this formula for you today, and that involves using the completing the square method. So let's come back here and practice using our completing the square method to solve quadratic equations. So question number 1. The first thing we do is we keep the x squared and the 6x on the left-hand side, and we move the negative 1, or the 1 which is across the other side, to make a negative 1. Then we complete the perfect square by halving the 6, which is 3, and squaring it. 3 times 3 makes 9, and adding 9 to both sides of the equation. That means that I have a perfect square on the left, which I can factorize to be x plus 3 in brackets all squared. And I can also simplify the right to be negative 1 plus 9, which is 8. Then I get rid of all the stuff with the x. So the first thing I do is get rid of the squared by square rooting. That would give me plus or minus square root of 8. Then move the 3 across to the other side. So plus or minus square root of 8 minus 3. The square root of 8 can be simplified. It is square root of 4 times square root of 2, and the square root of 4 makes 2 root 2. Plus or minus 2 root 2 minus 3 is the answer. Let's do that again for question 2. First of all, we are going to keep the x squared and the minus x. And we're going to move the 3 across the other side, so positive 3 over on the right. Then, to complete the perfect square, we have to halve the negative 1, that would be in front of that x. So we have negative a half, and we have to square that, which would be a positive 1, and 2 times 2 is 4. So it's a quarter that I need to add. So I add a quarter to the left, and I add a quarter to the right. Factorising the left, I get x minus a half in brackets squared. Simplifying the right, 3 plus a quarter is 3 and a quarter, but I prefer to have an improper fraction, so I'm going to leave that as 13 over 4. Then I get rid of the squared on that bracket. Oops, I don't need the brackets anymore, and it would be x minus half equals, square rooting means I need a plus or minus, square root the 13, and square root of the 4 is 2. Last of all, I'm going to move the half across the other side, so I have plus or minus square root of 13 over 2 plus a half. Because I have a common denominator, that would be better written as plus or minus square root 13 plus 1 all over 2. Okay, so now that we've revised that, coming to our new work today, we are going to not just give you the formula, I'm going to show you where the formula comes from, which is ax squared plus bx plus c equals 0. Now, to complete the square, it's going to look a little bit weird, but that's because of all the letters that are in there, but it's the same process that we've been learning. The first problem we have, though, is that we always have monic quadratics when we do completing the square method, and this one has an a in front of it. So the first thing I'm going to do is divide the whole equation through by a. That would give x squared plus b over ax plus c over a equals 0. Now I'm going to keep my x squared and my b over ax on the left-hand side and move the c over a across to the other side. So it becomes a negative c over a. Now I'm going to complete the perfect square. So I take whatever's in front of the x, so that's the b over a, I have to halve it, so it is b over 2a, because you're dividing it by 2, the 2 goes on the bottom, and then you need to square that, which means I would have b squared over 4a squared. Okay, that's what I'm going to add to both sides. I have x squared plus b over ax, and I'm adding b squared over 4a squared to both sides. Oh, I keep putting a c there. Let's put 4a squared. There we go. All right, then I'm going to factorize the left-hand side, which we know is always half of what's in front of the x, which will be a plus b over 2a in brackets squared. On the right-hand side, I want to get a common denominator so that I can put those fractions together. Now, the common denominator would have to be 4a squared, which is what the second fraction already has. The first fraction, I would need to multiply a 4 and another a to the numerator. So it'd be minus 4ac and plus b squared on the top. Okay, then to get rid of the squared on my bracket, I'm going to square root the whole right-hand side. So it'd be x minus b over 2a equals big square root over, I'm going to reverse the numerator so that the minus isn't sitting out the front there. I have b squared minus 4ac over 4a squared. And there would be a plus or minus at the front of that. Now the good news is that I can square root the bottom. So I'm going to rewrite that as plus or minus square root of b squared minus 4ac over, and square root in the bottom, square root of 4 is 2, square root of a squared is just a. Also, you'll notice that I've left off the minus b over 2a because I want to move that across to the other side. So I'm going to put minus b over, actually it becomes a plus when I move it, so plus b over 2a. Oh, no, that sign's wrong, sorry, that should have been a plus. I copied that incorrectly from above. So it should have been a plus, so it is a minus when I move it across to the other side. Then I have a common denominator with that fraction. So I'm going to push it all together to have 2a on the bottom. I'm going to put the negative b over here first, so it's minus b plus or minus big square root of b squared minus 4ac. And that is the quadratic formula. Now, the good news is that you don't have to memorize how to derive that formula, but it's just interesting at this level of maths to know where some of these things come from and not just have them magically appear. So that's the formula, and you can see it over here again on the next page, the quadratic formula. Now, just like the completing the square method, the quadratic formula can be used to solve any quadratic equation, particularly the ones that you cannot factorize. So we're going to use the quadratic formula on these couple of examples here to show you how it works. So question number 1, our quadratic is 3x squared plus 4x plus 1 equals 0. I'm going to write the quadratic formula down. It's x equals minus b plus or minus big square root of b squared minus 4ac all over 2a. Okay, then the numbers that I need to sub into that formula come from over this original question. Okay, so the a is whatever's in front of the x squared, the b is what's in front of the x, and the c is the number on the end. Don't include the x squared or the x, it's just the numbers in front of those that we use for the formula. So substituting those in, we're going to get minus b would become minus 4 plus or minus big square root. B squared is going to be 4 squared minus 4 times a, which is 3, times c, which is 1, all over 2a, which would be 2 times 3. Now, it's often a good idea to work out the part that is underneath your square root sign. So using my calculator, I'm going to type in the 4 squared minus 4 times 3 times 1, which gives me a 4. So it's minus 4 plus or minus square root of 4 over 2 times 3, which is 6. Now, this happens to be a very nice question Because the square root of 4 is a nice number, it's 2. So I have got minus 4 plus or minus 2 over 6. And as I said, because this is such a nice question, I can even go a step further and work out the two solutions from there. So to work out the first solution, we're going to work out what minus 4 plus 2 all over 6 is. If you want to, you can type it in your calculator. So we're typing in minus 4 plus 2 over 6, and that gives me my first solution, which is negative a third. The second solution, all I'm doing is changing the plus 2 to a minus 2, because it's that plus or minus that gives us the two solutions. So I put a minus in there, my second solution is negative 1. Now, not very many questions that ask you to use the quadratic formula come out with such nice answers, because that means that we probably could have factorized that equation. But that's okay, let's try the next one, and we're going to do the quadratic formula again. This time it says to do our answers correct to 2 decimal places. Okay, so the quadratic formula is x equals minus b plus or minus big square root of b squared minus 4ac all over 2a. The a, the b, and the c come from the numbers in front of our x squared, x, and the constant, respectively. So let's sub that into the equation. Minus b would be minus minus 12. The two minuses would just become a plus 12. Plus or minus big square root b squared will be negative 12 squared. I've put that in brackets to make sure that we square the negative on that 12. And then we have minus 4 times a, which is 3, times c, which is negative 3, all over 2 times a, which will be 2 times 3. Okay, like last time, I'm going to simplify the part that is underneath the square root sign. So if you want to use your calculator for this, that would be fine. It would be, actually without square root, it is negative 12 squared minus 4 times 3 times minus 3, and we get 180. So it's 12 plus or minus square root of 180 all over 6. Now there's the possibility that I could simplify the third down if I wanted to keep the answer exact, but this question did ask me to give 2 decimal places. So I'm going to type this in. It's going to be 12 plus square root of 180 all over 6. To 2 decimal places, that would be 4.24. The second solution is just putting the minus sign in front of that square root of 180. And we get minus 0.24. Okay, so we've used the quadratic formula twice, but there is an extra section to this topic that we need to look at. So the next part says, consider the quadratic formula. We can use what is called the discriminant, and this discriminant is taken from the quadratic formula. It's the part that is underneath the square root sign. It is the b squared minus 4ac. The symbol for discriminant is a triangle. Okay, so we say discriminant is equal to b squared minus 4ac. If we calculate this part first in any question, it will tell us how many solutions the quadratic equation should have, because it's all about what's happening with that square root and the plus or minus in front of it. If the number underneath that square root sign came out to be negative, we can't square root a negative, and that would mean that there are no solutions, 0 solutions exist for that quadratic equation. And that is quite possible. There are quadratic equations out there, plenty of them actually, that do not have any possible solutions. Okay, so just remember, if your discriminant is less than 0, it means that there is no solutions, and the reason for that is because we can't square root a negative. The second option is if the discriminant is equal to 0. If what is underneath that square root sign equals 0, then we're plussing and minusing 0. We're not adding or subtracting anything off, and we end up with only one solution, not two. Okay, so equals 0 means one solution. And anytime the discriminant is greater than 0 means that we will have two possible solutions, or two different solutions. Okay, so let's practice using that. Question 3 here says, determine the number of solutions to the following quadratic equations using the discriminant. Okay, so the formula for discriminant is the triangle, which means discriminant, equals b squared minus 4ac. From our equation over here, the a would be a 1, that would be sitting in front of the x squared, b is 6 and c is 2. So let's sub that in. It would be 6 squared minus 4 times a, which is 1, times c, which is 2. Calculating that, it equals 28. Okay, so the number itself isn't particularly important, but because it's positive, which we say because it's greater than 0, and you can look back over here if you like, greater than 0 means that there are two solutions. So I'm just going to say, therefore, there are two solutions. And if we wanted to, we could then use the rest of the quadratic formula and actually find what those solutions are. Let's try again for b. Let's use our discriminant, which is b squared minus 4ac. And we have our a, b, and c from our equation, and sub those in. So b squared is going to be minus 5 squared, minus 4 times a, which is 3, times c, which is 4. Calculating that, you get a negative 23. Again, it's not the 23 that's the key thing here. The fact that it's negative means that it's less than 0, and less than 0 means that there are no solutions. So you could try completing the square, you could try using the full quadratic formula, and you will not be able to ever get solutions to that quadratic equation. Okay, part C. One more time, the discriminant is equal to b squared minus 4ac. A, b, and c from the equation, let's sub them in. b is 3, so 3 squared minus 4 times a, which is minus 2, times c, which is negative 7. That equals negative 47, which again is less than 0, which means there is no solution to that equation either. Okay, so that is it. That's the end of our exercise and also the end of our topic. So can you finish off 8i, please?